Welcome back, grade 10 math. Today's lesson is on section 5.3, common factoring. Okay. In this section, we're going to learn how to go from standard form to factored form. So we're going to go from standard form to factored form. In sections 5.1, 5.2, we learned how to do the opposite. We learned how to go from factored to standard. Going from factored to standard, we used the FOIL method. We did a lot of multiplication to expand and get rid of the brackets. Okay. Factoring is the opposite. We're going to put this equation back into brackets. Okay, so FOIL was a lot of distribution and multiplication. Factoring is going to be a lot of division. Okay, before we can get started, let's just review what a factor actually is. Okay, a common factor is a number that is a factor of all numbers in a set. Okay, and what I mean by a factor, it's a number that divides evenly into all numbers in a set. So if I give you a set of numbers 4, 6, and 8, okay, 2 is a factor of all of those numbers. 2 goes into 4 twice, into 6 3 times, into 8 4 times. Okay, it divides evenly into all 3 of those numbers. Okay, a greatest common factor is the greatest number and or variable that is a factor of 2 or more numbers or terms. Okay, so the greatest common factor is the greatest term that divides evenly into all the numbers. Okay, 1 also divides into 4, 6, and 8. Okay, 2 divides into 4, 6, and 8, so 2 would be the greatest common factor because it's greater than 1. Okay, and a common factor doesn't necessarily have to be just a number. Okay, it can be a number and or a variable. Okay, so we have to remember that when we go through this section. Okay, section 1, monomial common factoring. There's 3 sections to this lesson. Monomial common factoring, so common factoring one term. The other section is going to be binomial common factoring, so we common factor a binomial. And section 3 is going to be factoring by grouping. Okay, so in order to common factor out one term of a polynomial, we first remove the greatest common factor as the first factor, and then divide each term by the greatest common factor to obtain the second factor. Okay, let's take a look at what that looks like, and I'll explain algebraically why we're allowed to do this. Okay, so if I give us the polynomial 6x plus 3, okay, let's look back at our rules. To factor a polynomial, we remove the greatest common factor as the first factor, and then divide each term by the greatest common factor to obtain the second factor. So step number 1, let's remove the greatest common factor. We have to determine what the greatest common factor is. Okay, we know the greatest common factor can be a number and or a variable. So let's find the greatest common factor of the coefficients first. Okay, so of 6 and 3. The greatest common factor of 6 and 3 is 3. Greatest common factor of the variable part, well, the 3 doesn't even have a variable attached. Okay, so there is no common variable between the 6x and the 3, so there's nothing we can common factor as a variable. Okay, so the greatest common factor of this whole polynomial, okay, we're going to combine the coefficient greatest common factor and the variable greatest common factor. Okay, in this case there is no variable greatest common factor, so the greatest common factor of the whole polynomial is just 3. Okay, now, so our steps are to remove the greatest common factor as the first factor. Okay, so we're going to take a 3 out of the 6x plus 3. Okay, we've taken that out. Now our next step is to then divide each term by the greatest common factor to obtain the second factor. So I'm going to divide the 6x and the 3 by the 3 that I took out to give me my second factor. So I have 6x, I have to divide that by 3, and I have to divide the 3 by 3. Okay, the result of this will give me the 2 factors of 6x plus 3. Okay, I know I'll be able to simplify this because I know 3 goes evenly into the 6x and into the 3. If I simplify this, 6x divided by 3 gives me 2x, and 3 divided by 3 gives me 1. Okay, there are my factors of 6x plus 3. My factors are 3 and 2x plus 1. Okay, good. Let me try and explain why we're able to just take out a number and then divide by that same number. Okay, So I have 6x plus 3. Essentially what I've done is multiply this by 1 in a fancy way, okay? The reason why when I take out the 3, the reason why I have to then divide everything by 3, okay? So I'm taking out a 3, so I'm now multiplying this whole thing by 3. In order to keep this equation equivalent, if I've multiplied it all by 3, I have to then divide it all by 3 in order to keep it equivalent, okay? Essentially what I've done is I have multiplied 6x plus 3 by 3 over 3. Okay? And we know 3 over 3 is 1. Okay? So essentially all I've done is multiplied the 6x plus 3 by 1 in a fancy way. So this equation is still equivalent once I've simplified these terms on the inside. Okay? It's still going to be equivalent to our original equation. We've just multiplied it by 1 in a fancy way. Okay? To put it into its factors. Okay? I hope that maybe helped clarify it a little bit. Let's go on and do some more examples. Okay? So, if we want to factor 5x plus 20, we need to find the greatest common factor of the coefficients. So of the 5 and the 20, the greatest common factor is 5. Greatest common factor of the variable part, well, once again, there is no variable with the second term. Okay, so we can't common factor out any variables. That means the greatest common factor of this whole polynomial is just 5. So our steps are to remove the greatest common factor from the polynomial. So I've taken that out, taken it outside of the brackets, and my next step is to then divide each term by the greatest common factor. I know I'll be able to simplify because I know 5 goes evenly into 5x and 20. So this will give me 5x divided by 5 is just x, and 20 divided by 5 is 4. So there's my answer there. 5 and x plus 4 are the factors of 5x plus 20. Let's do one more example like this, this time having a negative. Okay. Step number 1. So I want the factors of negative 5x plus 20. Okay. I need the greatest common factor of the coefficients of the negative 5 and the 20. Okay. If I have a negative term out front, I always want to factor out that negative term. Okay. So the greatest common factor of negative 5 and 20 is going to be negative 5. Negative 5 goes evenly into negative 5 and into 20. Okay. The greatest common factor of the variable, well, once again, there is no variable attached to this 20, so I can't common factor out any variables. So my greatest common factor of the whole polynomial is negative 5. My steps are to take out the greatest common factor from the polynomial, okay, leave the polynomial inside brackets, and then divide each term by the greatest common factor. And once again, I know it'll go in evenly into both terms, so I can simplify. This gives me negative 5. Negative 5x divided by negative 5 is just x. 20 divided by negative 5 is negative 4. Okay, so those are my factors of negative 5x plus 20. Okay, let's try one where there is a variable common factor. Okay, so if I want the factors of 8x squared minus 7x, I need to first find the greatest common factor of the coefficients. Okay. Now, if you think about it, the greatest common factor of 8 and 7, there's nothing other than 1 that goes into both of those numbers evenly. Okay. So my greatest common factor of those coefficients is just 1. The greatest common factor of the variable parts, I have an x squared and an x. Okay. So with this first term, I have an x squared. An x squared, we remember, is x times x. Okay. And then with this term, the 7x, so I have an x with that one. Okay, so all I can take out is 1x. Okay, so all they have in common is they both have 1x. The x squared has 2 x's, the 8x squared has 2 x's, sorry, and the 7x just has 1x, so all I can take out is just 1x. So my greatest common factor of the polynomial is the combination of the common factor of the coefficient and the variable. So my greatest common factor of the polynomial is 1x. Okay, so now I go ahead and take that out from 8x squared minus 7x. So I take out my 1x, and then I divide each of the terms in the polynomial by that greatest common factor. Good. And this will give me 8x squared divided by x. When we divide variables with exponents, remember, if it's the same variable, we just subtract the exponents. So 2 minus 1, that leaves me with an x to the 1. So 8x squared divided by x to the 1 just gives me 8x. Okay. Minus 7x divided by x. Those x's cancel, and I'm left with just the 7. Okay. So these are the factors of 8x squared minus 7x. Let's try another one like this. Okay. So if I have 25x to the 6 plus 15x to the 4, the greatest common factor of the coefficients, 25 and 15, is 5. 5 goes evenly into 25 and 15. Okay, and that's the greatest number that goes evenly into both of those. The greatest common factor of the variable part, okay, the variable being the x to the 6 and the x to the 4. Okay, so remember, x to the 6 is really 1, 2, 3, 4, 5, 6 x's. Okay, x to the 4 is 4 x's. 1, 2, 3, 4. Okay, so all I can do, these terms both share 4 x's. Okay, so I can take 4 x's out from both of these terms. A quick little rule, okay, the greatest common factor of the variable part is the variable with the least exponent. Okay, so these both have an x. Okay, one's an x to the 6, one's an x to the 4. The greatest common factor is the one with the least exponent. X to the 4 has the least exponent, so I can take out an x to the 4. Okay. Now, my greatest common factor of this polynomial is the combination of the greatest common factor of the coefficients and the variable part. So my greatest common factor of the polynomial is 5x to the 4. So my rules, I take the 5x to the 4 out from the polynomial. Okay, and then divide each of the terms by that greatest common factor. 25x to the 6 divided by 5x to the 4. 15x to the 4 divided by 5x to the 4. Okay. Go ahead and simplify inside the brackets. I know I'll be able to simplify because by definition a greatest common factor goes evenly into both of the terms. Okay, 25 divided by 5 is 5. X to the 6 divided by x to the 4. 6 minus 4 is 2. So I have 5x squared. Is that simplified? And then 15x to the 4 divided by 5x to the 4 is just 3. Okay, the x to the 4's cancel. 15 divided by 5 is 3. These are my factors of this polynomial. Okay. Good. Example 4. So we get a polynomial with 3 terms now that we're going to try and factor out a monomial. Okay, the greatest common factor of the coefficients. Coefficients are 21, 28, and 7. My greatest common factor is 7. Greatest common factor of the variable parts. Okay, these are the variable parts. Okay, so greatest common factor of the variable parts. Well, they all have x's. Okay, I'm going to common factor out the variable with the least term. Okay, with the least exponent, sorry. So we know if we don't see a number above the variable, it's a 1 there. Okay, so I have an x to the 4, an x to the 2, and an x to the 1. I know I have to factor out the variable with the least exponent. So I'm going to factor out just an x to the 1. And now for the y's, I have a y to the 3, y to the 5, and y to the 3. So they all have a y, so we can common factor out a y. And we common factor out the y with the least exponent. So we have a 3, a 5, and a 3. We can common factor out a y to the 3. So our greatest common factor of this polynomial is 7x, y, 3. Okay, so we'll need a little room to do this one because there's more terms. So we're going to common factor out a 7x, y, 3. Okay, so that means we're going to divide each term by 7x, y, 3. The negative 28x squared, y to the 5. Divide that by the 7xy cubed. And 7xy cubed divided by 7xy cubed. Okay. I know I'm going to be able to simplify this because I know the common factor goes evenly into all of these terms. So I have 7xy cubed. Okay, simplify this first term. 21 divided by 7 is 3. X to the 4 divided by x is x to the 3. Y to the 3 divided by y to the 3 is just 1. Okay? So I don't have to write anything there. The y to the 3's cancel. Minus 28 divided by 7 is 4. Okay? X squared divided by x is just x. Y to the 5 divided by y to the 3. 5 minus 3 is 2. So y to the 2. Plus 7xy cubed divided by 7xy cubed is 1. Okay? Don't just think that because these cancel, we're left with nothing. Okay? In fact, 7xy cubed divided by 7xy cubed is 1. Make sure you put that 1 at the end there. Good. You can check your answer by if we expanded this 7xy cubed back into this polynomial, okay, if we used our distributive property, we should be back at our original question here. Okay? So you can check all your answers by doing that. Okay? So these are our factors of this polynomial. Good. Okay, now let's take a look at this one. Okay, our first step is to find the greatest common factors of the coefficients, 5 and 7. Okay, that's just 1. Okay, so we can't really common factor out any numbers. Now let's look at the variables. Okay, this one has an x and a y, this one has an a and a b. They don't share any variables, so we can't common factor out any variables. So we can't common factor anything from this polynomial. So this one we can't factor. This one's in here just to remind us that we have to really pay attention to what the variables are. Okay? If this one has an x and a y and this one has an a and a b, those are not, they don't share any of the same variables, so we can't take anything out of it. Okay? Good. This is the last one we'll do for monomial common factoring. Okay? So this time I haven't given us the steps. This time I'm just going to go through it a little quicker and not show all of the steps. Okay? If you want to show all the steps, that's fine. Keep practicing that until you get more comfortable with it. Okay? So of the coefficients, I have a 4, a 10, and a 12. Okay? I can factor out a 2 from that. So I'm going to take out a 2. And these all have x's. The variable with the least exponent is an x squared, so I can take out an x squared. And these all have y's. The variable with the least exponent is a 2, so I can take out a y to 2. Okay. Once I divide each of these terms by this term I divided out. Okay. Oh, I shouldn't have drawn an equal sign there. Should be a bracket. There we go. So 4x squared y cubed divided by 2x squared y squared will give me 2y plus 10x to the 4y squared divided by 2x squared y squared will give me 5x squared. And then negative 12x cubed y squared divided by 2x squared y squared will give me negative 6x. Okay, so there's my answer for this one. So I didn't show all the work for this one. So if you have to, that's fine. Keep practicing showing all the work, okay, showing all the division. But then eventually you'll be able to just see the patterns and just be able to go right to this. Okay? Good. So that's it for monomial common factoring. This is as difficult as that will get. Okay? So if you can do this one, feel confident that you are comfortable with common factoring out a monomial. Okay. Now let's move on to binomial common factoring. Okay? So if we want to common factor 3x times y plus 1 plus 7z times y plus 1, okay? This doesn't really look the same as what we've been doing before. We've never seen binomials embedded in here. Okay? How we can think of it, okay? We have a 3x times something and a 7z times something, okay? We can common factor out these both of these terms have this green something. So we can common factor out that green something. Okay, we common factor out that green something. Okay, we have that green something up front, then we have 3x divided 3x times that green something plus 7z times that green something, and it's all, we're going to divide both of those by that green something. Okay, those green things are all going to cancel. Okay, cancel, 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 and what we're left with on the inside is just 3x plus 7z, and out front we have that factor of the green something. Okay, but in this case that green something is actually a binomial. It's y plus 1. So just think of it the same way. So we common factor out that green something. Okay, these both share a y plus 1. Okay, we can common factor out a y plus 1. So let's take out a y plus 1. Okay, we took out a y plus 1 from these terms, so we're going to divide each of the terms by y plus 1. And you'll notice that these y plus 1s cancel. Okay, you won't have to show all these steps every time, but just for the first one it's a good idea to show it. Okay, those y plus 1s cancel, and what we're left with is a y plus 1. And then on the inside, all we're left with is a 3x plus c. Okay, so we common factored out the y plus 1 from both of these, and what we're left with is the 3x and the 7z. Oh, 7z. Sorry, I forgot to write that here. 7z. Okay, we're left with that 3x plus 7z on the inside. Okay, so we took out the y plus 1, and we're left with the 3x and the 7z on the inside. Okay, so if we go ahead and try another example like this. Okay, I have a 2x times x minus 3 minus 5 times x minus 3. You'll notice both of these terms share an x minus 3. Okay, x minus 3 is a binomial. Okay, it's a polynomial with 2 terms. I can take out the x minus 3, and what I'm left with, each of these are going to be divided by x minus 3, so the x minus 3s are going to be gone, and what I'm going to be left with is 2x minus 5. Okay, so these ones are nice and easy, okay, nice and fast to do. Number 9, both of these terms share an r plus u. I can take out that r plus u. Once I divide both terms by r plus u, the r plus u's will be gone, and what I'll be left with is a 4w minus 3. Okay, so those are the factors of this polynomial. If I go through and expand this is what I'll be left with. Okay, if I expand it all, I expand all this, I'd be back at the same answer. Okay, good. Okay, section number 3, factor by grouping. Okay, so how we factor by grouping is we group terms with a common factor, separate the polynomials with an addition sign, factor the greatest common factor from each grouping, and remove the binomial common factoring. Okay, so we need to be good at binomial common factoring in order to do factoring by grouping. Okay, I'll reference these steps as we go through the first couple examples. Okay, so they probably don't make sense that first time I just said them, but you'll see what I mean. Okay, so I want to factor ax plus ay plus 2x plus 2y. Okay, you'll notice I can't, all 4 of these terms together, there's nothing I can common factor from all 4 of them. Okay, they don't all have an a, they don't all have an x, they don't all have a y, and they don't all have a 2. Okay, so we can't common factor anything from all of them. But if we group terms together that have a common factor, okay, so these first 2 terms both have an a, and these second 2 terms both have a 2. So if I put those into 2 groups, okay, I'll be able to do some work. So let's first do that. So group terms with a common factor. Okay, so I'm going to put ax plus ay together, and I'm going to put 2x plus 2y together. Okay, and I have to separate these with an addition sign. Okay, so I group terms together that have a common factor. Okay, and I separate them with an addition sign because we remember if we add polynomials, we're allowed to just drop the brackets. So if I dropped these brackets, I would be right back at our original question. Okay, so this is equivalent. Putting that addition sign between them keeps the equation equivalent. Okay, that's important. Okay, now what we have to do is remove the greatest common factor from each group. Okay, so look at just this group. The greatest common factor is just an a. Okay, so if I take an a out from both those terms, I'm left with an x plus y. And the greatest common factor of this group, I can take out a 2. Okay, if I take out a 2, I'm left with an x plus y. Now you'll notice this looks just like a binomial factoring question. Okay, and in fact the fourth step is to remove a binomial common factor. So if I remove an x plus y, I'll be left with a plus 2. Okay, because when I divide both of these terms by x plus y, the x plus y's will cancel, and I'll be left with an a plus 2. Okay, so there's my answer. Now, at this point you might say, hey, I could have, why didn't we group the ax and the 2x together? Those both have x's. And the ay and the 2y together, those both have y's. Let's try that and see if we get to the same answer. Okay, so we're going to group the ax and the 2x together. So ax plus 2x. And we're also going to group the ay and the 2y together. Good. And remember, separate them with an addition sign. Okay, that's an important step. Okay, let's take out a common factor. Ax and 2x, the common factor is x. I'll be left with a plus 2. For ay plus 2y, the common factor is y. I'll be left with a plus 2. Good. Now you notice these both have a binomial common factor. Okay, these both have an a plus 2 that I can factor out. If I factor out that a plus 2, I'll be left with a plus 2 times x plus y. Okay, good. So you'll notice I got the same answer for both of these. I mean, the factors are in a different order, but we know the order of multiplication doesn't matter. So these terms are equivalent. Okay, a plus 2 times x plus y is the same as x plus y plus a plus 2. So as long as we make sure to group terms that have a common factor together, okay, we'll end up with the same answer. Okay, good. Now let's try another one. Okay, so we have a 9x squared plus a 15x plus a 3x plus a 5. Okay, so in order to factor this, you'll notice that there's nothing that all of these terms have in common to factor out. But if we group them into two groups of 2, we should be able to do some work. Okay, so we'll notice that the 9x squared and the 3x, those have a 3 and an x in common. Okay, so we could factor those. We can put those as a group. And this 15x and the 5, we could common factor a 5 out of those two. So if we go ahead and put those into groups, okay, so I'm going to put the 9x squared and the 3x into a group, and the 15x and the 5 into a group. Separate with an addition sign, okay, because when we add polynomials we can drop the brackets, and this will keep our equation equivalent to what we had at the beginning. Okay, now let's do the common factoring of each group independently. So the common factor of 9x squared and 3x is 3x. Okay, if we divide 9x squared by 3x, we get 3x. If we divide 3x by 3x, we get 1. Okay, that's not a nice looking 1. That's better. Okay, now if I common factor this binomial, okay, I can take a 5 out, and I'm left with 3x plus 1. And once again, you'll notice these terms have a common binomial. They both have a 3x plus 1. So let's take out that 3x plus 1. When we divide both of these terms by 3x plus 1, they will cancel, and we're left with a 3x plus 5. So there's my answer for that one. Okay, good. So let's move on to number 12, where we're going to have to deal with some subtraction signs. Okay, but if we follow the same steps, we'll be fine. So just a quick reminder, when we factor by grouping, we have to separate the groups with an addition sign. Okay, that's an important part. Okay, because separating it with an addition sign keeps it equivalent, okay? Because when we add polynomials, we just drop the brackets, and we're back to our original question, okay? So let's keep that in mind when we do this question, okay? We can group together, okay, first of all, you'll notice there's nothing we can common factor from all of these terms, okay? That's the first thing you always look for when doing factoring questions, if there's anything you can common factor from all the terms, okay? And, you know, there's nothing I can common factor from all of them, okay? You look at the first three and you might think, hey, maybe I can take a 4 out from all of them, or maybe a 2, but then you look at the 9, and that ruins all those ideas, okay? So, but what we can do, we group 16x squared and 12x together, okay? We could take out a 4x, that would be good. And if we group the 12x and the negative 12x and the 9 together, we could take out a 3, okay? So let's do that grouping, okay? So let's put the 16x squared and the minus 12x together, okay? And let's also put the negative 12x and the 9 together and separate them with an addition sign, okay? You'll notice because of this addition sign between the polynomials, if we dropped all these brackets, we would be right back to this exact equivalent equation, okay? If I had accidentally separated these with a subtraction sign, that would have changed the integer value of both of those terms, and it would have given us an equation that's not equivalent to our original, and we can't do that, okay? So you have to separate it with an addition sign, okay? Good. So if I now common factor each of these binomials independently, like I said earlier, I can take out a 4x from the 16x squared and the negative 12x, and that gives me 4x minus 3. And I can also take out I have a negative 12x and a 9. Remember, when there's a negative sign in the first term, I always want to get rid of that. Okay, so I can take out a negative 3. Okay, negative 12x divided by negative 3 give me 4x. 9 divided by negative 3 will give me negative 3. Okay. Now let's simplify this. We have a plus negative 3 there. We know a positive and a negative beside each other. The negative sign wins. Okay, so I'm left with a minus 3 times 4x minus 3. Okay, and you'll notice that we can do some binomial common factoring now because these both have a 4x minus 3 as a factor. So if we take out the 4x minus 3, okay, that gives me, I'm going to take out the 4x minus 3, and what I'm going to be left with is 4x minus 3 actually, okay. So I took out the 4x minus 3, those canceled, and what I'm left with is 4x minus 3. I can simplify this further. I can write this as 4x minus 3 squared, okay. I have 4x minus 3 times 4x minus 3, something times itself. So I have 4x minus 3 squared. Okay? So in fact, I'm left with a perfect square trinomial. Good. So that's all for what we're going to learn today. What we learned, just a quick review, we learned that factoring is the opposite of expanding. Okay? So factoring is the opposite of FOIL. And this is useful for going from standard form to factored form. To find the greatest common factor of a polynomial, we find the greatest common factor of the coefficient and the variable part and then combine them. To factor a polynomial, we remove the greatest common factor as the first factor and then divide each term by the greatest common factor to obtain the second. Okay. And we learned that a common factor is not necessarily a monomial. We were able to common factor binomials, okay, right here, remember? And also to factor by grouping, we factor groups of 2 terms with a common factor. So we put them into groups that we know have common factors, and that produces a binomial common factor that we're able to do. Okay? So that's all we've learned today. Here's the homework to try. That's it for this lesson. Have a good day.